In this video, we are going to explore how we can use Pythagoras' theorem to calculate the missing length of a triangle, such as in this case, where we are aiming to determine the length represented by the variable x. First, let us understand when it is appropriate to apply Pythagoras' theorem. The initial requirement is that the triangle must be a right-angled triangle, which means one of its angles must be exactly 90 degrees. If the triangle does not include a right angle, such as in this example here, then Pythagoras' theorem is not applicable and we would need to consider an alternative mathematical method for solving the problem. Additionally, it is crucial that we already know the lengths of two of the three sides of the triangle. It does not matter which two sides are known, as long as two sides have defined measurements. For example, in this triangle, we know that one side is 3 units long and another is 4 units long. Lastly, there must be one side length that is unknown and needs to be found, which in this scenario is the side marked with an x. The equation central to Pythagoras' theorem is the sum of the squares of the two shorter sides being equal to the square of the longest side, often expressed as a squared plus b squared equals c squared. Memorizing this equation is highly recommended as it is frequently used in various math problems. The letters A, B, and C correspond to the three sides of the triangle. The letter C is always reserved for the longest side of the triangle, which is known as the hypotenuse. This side is always positioned opposite the right angle. Once we have identified C, the remaining two sides can be labeled as A and B in any order, meaning it does not matter whether A is on the left and B is on the top, or vice versa. What truly matters is that C is accurately assigned to the hypotenuse, and the other two sides are labeled as A and B accordingly. To use this equation effectively, we simply substitute the numerical values corresponding to the letters into the equation. For instance, if side A is 4 and side B is 3, we write 4 squared plus 3 squared equals c squared. Solving this like a typical algebraic equation, 4 squared is 16 and 3 squared is 9, so the sum is 25, which equals c squared. To isolate c, we take the square root of both sides, which gives us 5, and thus the length of x is 5 units. Let us try another example that includes decimal values and requires a calculator. In this case, we are again solving for an unknown side labeled x. The first step is to label the sides A, B, and C. Here, the unknown side is C, as it is the longest side. We write the equation a squared plus b squared equals c squared, and then insert the values. So we have 1.7 squared plus 3.2 squared equals c squared. Since we are solving for x, we can substitute c with x, so the equation becomes 1.7 squared plus 3.2 squared equals x squared. Using a calculator, we compute the sum of 1.7 squared and 3.2 squared, which equals 13.13. Therefore, 13.13 equals x squared. Taking the square root of both sides gives us x equals 3.62, accurate to three significant figures, as usually specified in exam questions. The missing side in this case is 3.62 centimeters. Now let us examine a typical exam-style question where the triangle's corners are labeled with letters such as x, y, and z. In problems like these, when we are asked to find the length of a side such as xc, it means we need to determine the length between the corners labeled x and z. This is the side we are solving for, so we can place a question mark there. Despite the labels, we proceed by identifying and labeling the triangle's sides as A, B, and C according to the rules discussed earlier. From this point forward, we can ignore the corner labels and just focus on applying Pythagoras' theorem. We write out the equation a squared plus b squared equals c squared and plug in the known values. For example, 5.6 squared plus 10.5 squared equals c squared. Entering this into a calculator yields 141.61 equals c squared. Taking the square root of both sides results in c being 11.9, so the length of xc is 11.9 centimeters. Let us go through one final example of this style. In this question, we are tasked with finding the length of side AC. We begin by marking this unknown side with a question mark. As before, we can disregard the labels at the triangle's corners and simply label the triangle's sides as A, B, and C. Then we apply the familiar equation a squared plus b squared equals c squared. Here, 8 squared plus 11 squared equals c squared. This simplifies to 64 plus 121 equals c squared, giving us 185 equals c squared. Taking the square root of both sides gives us 13.6 equals c. Therefore, the length of side AC is 13.6 centimeters. That brings us to the end of this video. We hope you found it helpful. If you did, please consider giving it a like and subscribing for more educational content.